Hello, Ignesh. Am I audible? Good morning. Your good name, please. Okay, thank you, Ignesh. So, I think maybe 9 members yet. How much time will the people join? Good morning, Sai Prajwal. I'm not able to change my camera. Guys, do anyone of you know how to change the camera settings? I did it. Okay. I can change my camera settings right now, right? I can change to other camera, but it's not allowing me to change to other camera. Okay, fine. Even this is good. So, are the people joining still, or shall we start? Only 14 people. I got 75 registrations. Okay. Okay, then before going which class or which, so that I can understand and to where I can take you to the people who I'm talking about them. Guys, my grade 8. Oh, nice, nice. Last year, nice. Okay, others, we only have 15 people here. Okay, then. Okay, guys. So, as I have even school people, 8th grade people here, I'll be going from basics. First, I'll cover the basics of Arduino and ESP. Then we'll go into different projects and higher level of circuits and also coding. Okay. So coming to the first time, what we'll be learning in the session, I'll be teaching you about what a microcontroller is, and you'll be getting different ideas on how to do use different sensors for different applications, and also how sensors work. You'll learn how sensors work, build spending any rupee. You can build your own circuits and simulate and code them and simulate and check their behavior also. Use your circuits carefully without damaging the microcontrollers and costly components in it. So without waiting, let's move ahead. Before that, I want to show you what is capable with Arduino, what you can do with Arduino and ESP. Let me show you. Okay, not this, not here. It's here. Are you able to see this, guys? I'll share that. This is my home applications. This is my security camera which I made with ESP camera, and this is my automatic pump system that will water plants based on the timing and input day interval which I gave it, and also it will run for the duration which I mentioned it. So and also about this camera, human has come into the feed. So Arduino's very basic, but they can do a lot of sophisticated things which you can't imagine. I mean, you can even a school student can start with Arduino, and even a PhD student can make a project with Arduino. Even still today, PhD students and research students use Arduino for different projects. Arduino is as basic and also as advanced it is. And even I use Arduino in DRDO when we are doing flight controller. When I'm building the flight controller for the drone, I use the Arduino and I made the flight controller, basic version of flight controller on it. Then we switch to different things. So that's about the basic topics which you are going to learn. So are you guys excited? I mean, okay, let's go ahead. And it's about me. For the people who know me, I am Srinivas, robotics engineer, embedded systems expert, and drones expert. I worked in DRDO on drones. For the people who don't know me, these are my hobbies: building stuff, breaking stuff. These are my hobbies. Okay, so let's go. And now coming to the main topic: why microcontroller? Why do we need a microcontroller in the first place? And what is a microcontroller? Basically, circuits which you build with light, fan, or switch, they don't have any intelligence on their own. They can't make any decisions. They can't make any logics. So you put microcontroller as their brain, and you tell the microcontroller how to interact with the other sensors, actuators, everything. So microcontrollers are logic makers, decision makers, and they do actions. They make the other components do actions. They take the inputs, they process, and they make the actuators do the output. Okay. Yes, I'll share the PPT in the group. Yeah, in the community, I'll share the PPT. And now coming to the terminology, before going into circuits and building something, know some few basic terminology so that we can talk in the microcontroller language. So microcontroller has pins which you can connect to other sensors, other actuators, LEDs, etc., etc. So those terminals are called pins, and those pins, there are different types of pins. GPIOs, general purpose input output pins. These are very general purpose pins. You can use them for on and off in LED, or motor from a motor driver. Yes, everybody will get a certificate who attended. Who attended will get the certificate. Don't worry about the certificates. If you are in the session and if you learn something, that is more valuable than getting a certificate. Okay. So the point here is there are different types of pins. In the basic pins are general purpose input output pins. You can use general purpose input output pins for everything. You can read them. I mean, you can take inputs from them, and also you can give outputs from them. So those are GPIOs, and in those GPIOs there are subdivisions: digital pins and analog pins. Digital pins are like switch. There is only 0 and 1, low and high. You on a switch or off a switch. That's it. That's the only two modes in digital. But in analog, there is something. I mean, it's a continuous line. It's like a regulator of your fan. It has 0 off, and it has something in between 0 and high, and 2. and at the high 4. So analog is like a continuous line or a regulator which has something between 0 and 1, I mean low and high. Okay, and then comes the signal pins. These are the pins specially designed to simulate a signal to send to send a message to a sensor or to read a message from the sensor. They work on different protocols. You'll be learning what's the use of signal pins when you work with the I2C sensors, UART sensors, etc. like that. So those are signal pins. And comes to the power pins. These are very much common pins, and you need to be very careful with them. They they take power, also they deliver power. Few with which you can power your sensors. So those are the power pins. We have VCC and ground. VCC means positive terminal which gets 5 volts, called VCC, and ground is a negative terminal which is 0. You can it as 0. Okay, this is the terminology of the microcontroller. Whatever the microcontroller you take, all the microcontrollers have the same pins. These are the basic pins which every microcontroller have. Okay, this is about the pins, and also a few points you need to know about how each pin work and how each pin behaves, so that you can write the code depend I mean on the you can write the code on using which pin you want to use. Okay, that's about the terminology. And here you can see Arduino. In this Arduino, here red and black are power pins, and this green are analog pins. Here this orange, yellow, sorry, I mean this yellow and orange, this side, all these pins are digital pins for Arduino. Okay, this is about Arduino. And now let's go into safety precaution. Today I'm not going to take much time in the theory, because theory about the microcontrollers is very minimum, I mean bare minimum you need to know. The more you do practically, the more you learn about microcontrollers. And also the more projects you do, the more debugging you do, the more depth you go into microcontrollers. So that's why I don't want to take much of the theory. I just want to brief you about the basic things which you need to know before getting into project building, I mean, or first circuit building. So first, before, I mean, this is the safety precautions that you need to take care when you are working hands-on. When you're working in software, I mean, simulation, you won't be burning anything. But these are the safety precautions you need to take care when you are working hands-on with your kit, with your microcontrollers. First thing, powers. Microcontrollers are low power devices. They only take 5 to 3.3, and some take more than 3.7 to 18, like that. You need to read the data sheet for each microcontroller board, development board, to know about the specific use case, I mean specific power delivery or power rating of that microcontroller dev board. So for that case, I have an example of Arduino board here, Arduino Uno board. This is the datasheet of Arduino Uno. Oh, wait, let me share that. Sorry. Yeah, this is the Arduino Uno board, datasheet of Arduino Uno. So when we see here, it says about the processor, flash, memory, etc., etc., and the things which we need the most are here. Yeah, Win Max. The Win Max is maximum input from Win pad. Win is this. I mean this pad. This X1 pad is the Win pad for Arduino. So from that you can give 20 volts. But from the USB connector, you should not give more than 5.45 volts. If you give more than 5.5 volts, you will burn it. So that's the point here. This is about Arduino. I mean, I am showing you the data sheet because you need to go through data sheets of different microcontroller boards and also sensors to know about their voltage ratings and also how they work. Until and unless you know how they work and how what are the voltage ratings and power of a board or sensor, you might burn them, or you don't. I mean, you might get into a debug loop which you can't come out until and unless you learn about a microcontroller or sensor. So that's about. I mean, I have only gone through the basic surface of the data sheet. When you are working on a specific use case or you are building a PCB, you will read the entire data sheet and you will understand how circuits are connected, how each power module is connected to other pin, how are pins getting powered. You will know everything then. Okay. Now coming back. Yep. Uh, and also the reverse polarity. You should never reverse the VCC to ground, ground to VCC. Careful with this. Without knowing, you might do it because some people might solder different color wires to different notations. Some people use red for the ground, black for the VCC. So you might get confused. But before that, just go through the circuit, look at the wiring, and then connect the power. Okay. And also always remember to isolate the high power electronics from microcontroller. Microcontrollers are low power electronics. They run on low voltages and low currents. So they can't power motors. They can't run the motors. So it's better to keep them away from the microcontroller so that your board will be not heated, your board will be in safe condition, it won't get burnt, or else your project won't be not working. So it's just you need to calculate the power estimations beforehand and then take components and power your microcontroller board. Okay. And about the short circuits, this is a very common thing which I did think that damages in a circuit will be the microcontroller, and that's okay. Now let's get into circuits. Whatever the circuit you take, however big, complex, or mm, heavy, lots of component involvement, or complex wiring is there, whatever it may be, you can break that into this simple framework: input, process, output. In input, you'll take sensors. Sensors will be the input. Sensors will be giving the state of the machine, or state of the machine and other data which you will be processing. Processing will be done in the microcontroller. Microcontroller process the input, the data which comes from the sensor, then it will deliver it to the output. Then output actuators, motors, LEDs, speakers, buzzers will act accordingly to the action that is commanded by the microcontroller. So this is a simple framework which you have to remember for whatever circuit you are going to design. Now, before going to ESP, I want to make few simple circuits in simple circuits with Arduino. So then we can get comfortable with Arduino and all other simulation frameworks. Then we can go to ESP. Okay. So okay. For the beginners who don't know Tinkercad, just Google Tinkercad and you will get into the dashboard, sign up, create your account, and then click create here and build your circuit. why think, I mean, many colleges and schools, they encourage to you people, they encourage students to use Tinkercad. You know why? Because it's very easy, and also coding here can be taught to even a fifth grade student. That's not an issue. So I took the Arduino here. I mean, let me put up a circuit, simple circuit, very simple circuit. Then I'll explain how to code and what are the components in the code that you have to understand and implement when you are going to code your own circuit. So I'm taking an LED. Anode is positive. I'll be connecting the anode to 3 D3, and cathode is ground. I'll connect it to ground. Simple circuit. Now, let's go to the coding part. I said Tinkercad is very easy, and you can even teach fifth grade students how to code. Tinkercad has, guys, are you able to see the screen right? How do we connect a motor without heat up? Yeah, I'll come to that. I'll come to that. I'll be teaching you about how to connect the motor also, and also how to build a two-wheel robot with ESP. If we have time, I'll tell you how to control it with your phone wirelessly, completely with Wi-Fi. Okay, let's go ahead now. So there are two blocks in the coding. I don't know. There are only two blocks. One which is on start, which will be called on start, and it will be run only once. Whatever you put here, that will be run only once. So put here, no, not built-in LED. Okay, let's put the built-in LED, which is this L. This L is the built-in LED, which will go high, and it will be on high because I'm not bringing it low. So I'm setting it high, and then here I'll change the code. I'll change which pin did we connect it to? We connected to 3, right? So we'll put 3 to high. High is, I mean, we are connecting digital pins. D3, digital pin. Only high and low. High means you will give on. High means on. You will give the maximum voltage which the microcontroller can give. It will be around 3 to 5 volts. So that will be fine. Then, okay. So, okay. We'll put this to high, and then we'll put it to search for delay. This is the only thing which I don't like in Tinkercad, because you need to search for all the blogs. Okay, let me show you uh, simple work. Then I'll move on to the actual coding, because here is a fifth grade. They can understand the code. So I'll teach you the actual code now. Let me simulate this and let's move forward. Yep. The L goes, the built-in LED glows, and even the red LED glows. We put high to both, so they both glows. Okay. Now let's stop the simulation. Let's go to the actual code. Let's write the code. Text. Let's go to text. Here, I have told you that there are only two blocks in Arduino. One is void setup, one is void loop. Void loops runs indefinitely. It runs forever. Void setup only runs one at only at the start. Here in the void setup, you will be defining the pins. Which pin does what? So So here I am defining the pin 3 to be output because I want to control the LED. I need to control the state of the LED to be on or off. So I want to I will putting it to the output. So once it is kept to the output, then in the void loop I can write high, and I'll give a delay of 1000 milliseconds, that means 1 second. Then right. So as we are using digital pins, we'll be using digital write 3 comma low. And semicolon is important after every statement. And then we'll add the delay again. So that will be in a blink loop. See, the LED glows on and off. Very simple code, right? Setup where you will set which pin does what. Screen is not clear. Is it the same for everyone or it's fine? And in the loop, you will be writing your logic and decisions so that it will be running continuously. How to implement digital? Now we'll read a pin state. We'll take an input in this circuit. Earlier circuit, we don't have any input. We only have process and output. Now we'll add input also. I am taking a push button which I'll be connecting to the 5 volt. It is little blurry. Okay. And another pin to D5. Now what happens here is when I push the button, the 5 volts from the ground, the 5 volts from the Arduino, which is 5 volts out from the Arduino, will be sent to the D5. Then in D5, we'll be reading the top highest voltage which the microcontroller give. If it is 5, we'll say the button is pressed. If it is low, I mean if the D5 is not getting any voltage, then we'll say it off. The button is not pressed. Okay, so we'll write that code here. Before that, for every pin you want to code, you will be mentioning the state of the pin, which state the pin is in. Now, as we want the pin 5 to be input, we want to read the state of the button. We'll be taking it as input. Okay. Now here in loop, in void, in loop, we want to read the button continuously, read the button state continuously. So here, before that, we'll declare a variable so that we can store the reading state of the button there in the variable. So I'll store a integer variable because we are only having 0 and 1 here. So we can store any integer variable. I'll say val for it. Okay, now val equal to, we have to read the input. So it's a digital input. So digital read. Digital read the pin number. Pin number is 5. Now I have to write the conditions. If this is a condition loop, I mean condition statements, these are condition statements, these are called condition statements because they only execute if a condition satisfies. So if val equal to 1, sorry, equal to 1, val equal to 1, if you put only 1 equal to, then we are assigning the value to it. If you put 2 equal to, then we are comparing the value. 2 equal to means comparing the value. So we will be comparing the value now. If the value is equal to 1, then what we want to do, we want to turn the light on. So we will write digital light, right? What's that? Pin 3, right? 3 high. And when you're coding, please be careful. Arduino is case sensitive. If you put capital a small case letter in the place of capital letter, it will say there is an error. Okay, then we'll write the else loop also. If else matlab, now the state is not equal to 1, it will be 0. In the digital case, if it is not equal to 1, it will be 0, right? So we need not write the statement here. So we'll just write what to do, what action to do if it's not 1. Yeah, we can take this off. So now here we are reading the state of button. So that's why, okay, I did some mistakes here, probably. Digital read was not clear. Okay, digital. Okay, I misspelled it. Oh, issues with Tinkercad. Okay, maybe after this we'll move to another website where we can do much more efficiently and with much more good, better circuits. Okay, everything here will be gone. Okay. Wow, what happened? Okay, this is too few arguments with the function digital right. Sorry, sorry. Guys, you can correct me in between if I am not. I'm skipping something. Yeah. Now, what's happened? Okay. It says D3 exceeds the absolute maximum of 4 point damage the Arduino board. So in this case, what we'll do is it's better to connect resistors. In real world, you have to connect the resistors so that you won't burn your LED or you won't burn your board. Okay, digital pin 5, right? It turned on already. I guess there is something issue with the website. Okay, then I'll explain the same in Walkwe. Here you can use ESP32 also, ESP32 boards also, and also we have so much more components to work here. I feel Tinkercad is only to teach very beginners to how to code or circuit on Arduino or ESP. So what I feel is let's do it here. Okay, 10 and 5. Now we'll add LED to ground, and okay, we'll take a resistor here. Better. Yeah. Okay, code here. So let's write the code. And see here, actually Arduino works the same. It will be giving you suggestions on what to type, and you will be less at doing mistakes. So we connected it to pin 3, right? Pin 3 to output. Just less. Now pin mode 5 to input. Now let's, as you can do along with me if you have your laptop, if you are working, if you are joining from the laptops, you can go to the websites and you can try along with me. Okay, I'm reading the digital read into val. Now let's write the conditions. Val equal to 1. Sorry, the pin is 11, right, guys? Guys, you should be telling me that, right? The pin is 11, not 5 here. Okay. Now let's do the else condition too. I'll just copy paste here. Okay. Now it seems fine. So it will read at 11. Then it will tell what to do at pin 3. See here, it works. When you click the button, it glows. When it leaves the button, it goes off. The push button action is simulated like this here. So to read for a digital pin, you'll write digital read. To write for a digital pin, you mean to output for a digital pin, you'll put digital write. To input for input, you'll write sorry, you will use digital read. Okay. Okay. Now let's go to analog. Analog is almost similar. Digital. I mean, analog read and analog write are similar functions, are which are this demonstrated to you right now as digital functions. But in analog, as I've mentioned, see here they have mentioned the pins. I mean, in every uh, you will be on every sensor board, you will be known the pins. I mean, pins are mentioned very clearly so that you won't mistake it. Okay, VCC to 5 volts, ground to ground, and then the signal wire I'll be connecting to this 11, and here I'll be okay. This is input. We will be reading this as input, 11 as input, and 3 will be our output. Now, yes. Also in this case, I want to also mention this. You this in Arduino. There is a special case. You see this small symbol beside 3, 5, 6, 9, 10, 11. These are called PD. These are digital pins which can act like analog pins. This is a specialty of Arduino. So these are digital pins which can act like analog pins. So with the same, I can with the same 3 pin, I can write digital read, and also I can write analog write. But for analog rate there won't be high and low. It's not just high and low. You'll be having something in between high and low. You will be having low, you'll be having high, and also you'll be having something in between high and low. So for that, i'll be I'll be reading this analog value here, and then I'll write the 3 to val. I'll give the input as val for the 3. Now let's see what happens. Yep, it's at high. Oh, okay, we are getting high only. Okay, then let's try with analog pins. I guess there won't be any issue with this. Oh, sorry, guys. I am using a digital pin to read analog. Analog. I'm using a digital pin and saying it. That's the issue. This is how we debug. Sorry, I need to stop the. Now let's give it to some analog pin. I have given it to. Let's give it to A0. Then right here, A0 is input, and we'll be reading A0 and we'll be giving that to 3. See, it works with the potentiometer. The brightness of the LED changes with the potential. I mean, with the, see here, it goes dim, it goes bright, it goes dim, it goes bright. With the knob, potentiometer knob, the brightness goes. That is called. I mean, that is why. That is what the specialty of analog. You can take something in between 0 and 1, high and low. You can take something in between high and low. That is analog. Now, I guess you guys are very bored with all these simple circuits. Even for even if you want to go for PIR motion sensor, PIR motion sensor is also same. It has VCC. You will give it to 5 volts. VCC to 5 volts always. Ground to here also there is a ground to ground, and here you see D pin D, and also using any sensor in your circuit, just Google it, Baba. Google it like what are you using? We are using PIR sensor, right? PIR sensor out. When you see here, you see ground output and VCC to 5 to 12 volts. You'll be knowing the how much voltage to give to a sensor to work. Sometimes the voltage from the microcontroller won't be sufficient for the sensor to work. Then you have to get the power from outside, power from the battery, and we have to regulate it to the sensor. So that's one case. And also sometimes the power from the microcontroller, even the 5 volts from the microcontroller will be too huge, so the sensor will be burnt. Then we should step down the voltage, or we should look connect it to 3.3 volts. Then it will work. So it's better to look at the data sheets of sensors. Also go into what does a PIR sensor does. Okay, just here. Okay, we'll ask how does a PIR sensor work. Let's know how does a PIR sensor work. You see the what can I show you? Yes now. Okay, this notation is not good, but yeah. You see this here, this lens. This lens is called Fresnel lens. What does this? I mean, there is a simple IR light behind the Fresnel lens. Now, what does this Fresnel lens do is it will refract. It will refract the IR light into different directions, so that you will know who is. I mean, is there any person in motion before the sensor with the help of IR in 360 degrees. No, sorry, in 180 degrees, because you only have only 180-degree vision with the funnel lens. You'll be knowing up to 180 degrees. Without a funnel lens, you'll be only knowing in a pinpoint location, not in a 180 degrees. So funnel lens helps us to refract the light, IR light, into different directions, so that we'll be knowing if there is any person in 180-degree field of area. So that's the thing. Now, as I mentioned, we'll be knowing if any person is in motion in front of us, or if any person is in front of us, right in front of us. We'll be knowing with the use of PIR sensor. So we can use this to for burglar alarms and motion detections. Um, Yep. Also, even my camera does captures the person when he's in frame, so I can add the PIR sensor if to know if any person or object is in motion also. So that's the PIR sensor thing. So here we'll just read digital read, and the pin number is 10. We'll digital read pin number 10, and pin number 10 is input. Now what we'll do, I'm not writing condition now because I know if If there is something in front of a funnel or a PI sensor, we'll get 0. If there is nothing in front of it, we'll get 1. So and there is nothing in front of it, the light will glow, or of it, the light will light will stop. So I'll just give the val to it. So we'll get 0 and 1 out of this digital read also. So I'll be giving 0 and 1, or that is also mean that also means to high and low. When there is simulate motion, yes, we are simulating, so the bulb glows. So that's how PI sensor works, and this is very simple to you, because only see guys, with any sensor, whatever sensor you take, read the data sheet, get to know the power ratings of the sensor, then get to know the pins of the sensor. If you know the pins and power rating, half of your work is done. You know how to connect the sensor to your Arduino or ESP or any other board. Then, by knowing the pins, by knowing how the sensor works, you can write your code, you can write your logic, you can write your statements, condition statements, or any processing statements, so that it will does the job. I mean, if for PIR sensor now, we write a simple code, we write very simple code, and when someone is in front of it, the light glows. When no one is in front of it, the light stops. Cool, right? So that's it. I guess it's already 11. We should I take more sensors and explain you all about analog also, or should I go for ESP? Cool, cool. So why do we use ESP more than Arduino? Arduino is, I mean, Arduino is now developing it at a much faster pace. But even though most of the people go to ESP only, you know why? Because it has built-in Wi-Fi and Bluetooth. That is the major thing that will keep the form factor of the board very small and also very powerful. Very powerful. You will be having everything wireless connection in your arm. You will be having wireless connection and a much powerful processor than Arduino. You have more memory also, you have more pins, then you can more connect more sensors to it, and it's also much cheaper than Arduino. So that's the basic thing why you take ESP rather than Arduino. Okay, I'll just jump into the connections, and we'll I mean wait. Guys, now actually I told you that I'll be explaining you about sensors, wirings, and Arduino coding. I guess Arduino coding and Arduino coding is halfway done, and sensors, I explained you how to connect a digital sensor and analog sensor to digital pins and analog pins, and read digital inputs and digital inputs and analog inputs, and give digital outputs and digital outputs and analog outputs. How to give digital outputs and analog outputs. Now, what do I think is, uh, rather than simulating the same with Arduino, same with ESP, why don't we take it a step ahead and do wireless communication with ESP? What do you say? This is not what I'm planned for the workshop, but I thought I could give you a bonus for the workshop. And also, as very few members are in the session, I think I can speed it up a bit and I can give you the wireless communication with ESP. Guys, what do you feel? Manish, I need a suggestion from you. Have you understood how to code Arduino and how to wire digital and analog sensors? If that's okay with you, I'll jump directly into the wireless communication with ESP. And guys, in the age, sure, let's start. Okay, cool. And in the age of AI now, I'll show you the other website, which is a bonus part for you too. In that, you can use AI to wire your sensors to your board, and also if you describe your purpose with your circuit, what you are going to achieve with your circuit, it will write the code and it will tell you how to simulate also. You just need to know which sensors to use, which board to use, and how to use them. AI will help you a lot. Yeah. Okay. Let's take ESP32. And here for this thing, I am using uh, Remote XY app. Remote XY app. I'm using a Remote XY app in my phone, and also I have to generate code based on the layout in the Remote XY website. So you go to Remote XY website, you just click start now, and also you need to sign in. I already signed in. So this is the earlier version which I put. You drag and drop a button. Wait, I'll delete this. Yes, you drag and drop something here, and then you configure. As we are using it simulation, we are using the ESP32 board. So I clicked on ESP32 based, and we are using integrated Wi-Fi on the board. The board has inbuilt Wi-Fi, so we'll be clicking integrated Wi-Fi. And for the connection, we have to go for cloud connection, not for the Wi-Fi connection. When we are doing it on offline, we'll be doing Wi-Fi connection, and when we are doing it online, we'll be using cloud connection. And IDE is Arduino IDE because we are using Arduino programming language. So then click apply, done. You put whatever switches or joysticks, buttons, etc. you need in your UI here. And here in cloud server in connection, when you come to connection, uh, as you are simulating now, you don't need to put any SSID or password here. You need to put tokens here. I have made a token already, generated a token, and I named it ESP32. So I'm using the token here. You can just sign in. It's all free. You can just sign in and create your own tokens. ESP token. I'm using my token. I'm sorry. Clicked again. The only issue is the website is little slow. Rest all, it's so good. I mean, you can't, you don't get any free websites and free Wi-Fi, free ESP connections, which you can customize to your use in current trend is not available in any with any app or any website. So I find this very useful. Okay, now you click. Now just click the get source code. Now you'll get a code. It's a skeleton code. You have to write your own logic in here. So I'll copy this copy code and I'll go to here and I'll paste this. Before executing, I need to write my own logic, and also I need to install the remote XY library. So to install remote XY library in here, I'll just go to library manager, click add, and I'll type remote XY. Yes, this is this. So I'll just click on it and I'll go to sketch back. Now see, uh, here we have put one switch, right? We have kept one switch in our UI. So this switch is named as I haven't given any name to my switch, so it's just popped up as switch switch 01. It just popped up as switch 01. As I'm using the remote XY library to use a switch 01 object from that library, I need to write my code like this. So I'll just copy this. Now in setup, wait, I'll add the circuit. I'll add an LED, ground to ground, and to 19. To pin 19, I'm connecting the LED. So I'll write pin mode 19 output. Cool. Pin mode 19 output. Now here in the void loop, you need to use a switch. You need to use the condition of the switch. Whenever I click the switch in my phone, I need the LED to on in the simulation. So I'll write the logic like this, condition like this. If remote xy dot, this is important guys. Remote xy dot switch 01 is important. Okay. Then okay, sorry. Remote xy dot switch 01 is equal to 1. Equal to 1. See here, he already mentioned if switch is on, switch equal to 1, if switch is on, is off, I mean equal to 0 when it's off. So without all this also, I can directly write like this. Digital write. What's my pin? 19, right? 19 comma remote xy dot switch 01. Cool. Now let's run the simulation. Now here in the simulation, it will compile. Sorry, here I have to adjust the Wi-Fi and password. I forgot that. Yeah, wait, let it compile and it will give the error and then we can do it. Here the code, the token which I generated is already generated from the code. So I copied the code, so I got the token here. Now it will try to connect to Wi-Fi here. Wi-Fi symbol will pop up, but it can't connect as the Wi-Fi password and SSID are not mentioned here. And the security of walkway is really good. See, it tells us to connect to walkway guest without any password so that it can directly connect to the cloud using our Wi-Fi which is connected to the laptop. So I just change SSID here and I put the password blank. Then I'll begin there. Okay, it says there are some errors. Walkway guest character. Okay. Okay, we can. No. I'll put the password empty. Okay. There are double quotations here. Got it. Maybe the Wi-Fi society which I put earlier is correct. worked. Let's see. Let connect. Yeah, the Wi-Fi password SSID which I kept earlier is correct. Yes, it got connected to the Wi-Fi. Now, in my phone, I'll click on the add button here at the top right corner. I'll click on the add and click cloud server, and it got my token already here. So I'll just connect to my token. Yeah, I got the UI here. The UI which I kept in the website and I generated the code. The UI is loaded in my phone. Now when I click on, the light goes on. It's from here, not from the website, not from the code, or not from the buttons or anything. It's from wireless. I'm controlling it from here. It goes off. There is some latency, but it just works. And there is no other simulation website that you can simulate the ESP cloud connection, wireless connections in any other website. So that's the thing about this ESP32. I mean, Walkway ESP32. And I don't want to bore you much with the sensor connection and repeating the same code and same errors again and again. So I'll just go forward and I'll explain you the motor logic which Avinish asked me. Sorry. Yep. The motor connections which Avnish asked me, because in I mean in Walkway also we don't have motor driver. I mean the motor driver which we want for DC motors, not for stepper motors. We have a stepper motor driver, which is a bit hectic to use for normal DC motors. So in circuit design, the free plan, you'll get AI. It will just auto wire you 3 queries per day in free plan. It's also unlimited basic. Okay, let's go to the IDE. Let's not waste much time here. Yep, start from scratch. Okay, now we are simulation ready. Here, simulation ready only we have ESP on. I'm sorry, Arduino only. We have only ESP ready simulations in Walkway, which are really good. And okay, I have put the Arduino. So as I mentioned, we cannot connect motors directly to Arduino because motors need more voltage and more current than what this what the microcontroller uses and microcontroller can deliver. So now we'll use a motor driver L298M, a motor driver which will be directly connected to the battery, and that in turns powers the motors. The connections goes like this. uh, yeah. Mm. These are the power terminals, so that's why they are big, and these are the signal terminals. You will tell the microcontroller will only tell how to turn the motors from the from the motor driver. Microcontroller commands the motor driver to turn the motors in required direction. Microcontroller does all the processing, and motor driver gives the power to the motors based upon the microcontroller input. There are four wires here. One, two, three, four. One corresponds to this, two corresponds to this, three corresponds to this, four corresponds to this. Okay. When I give high and low here, high and low means a complete circuit will be completed. A closed circuit will be done. So the motor goes. Only when you give, if you're taking a 9 volts battery and a motor, when you give positive to one terminal and negative to another terminal, only then the motor turns, right? So here also you are doing the same. You are giving high to one terminal and low to another terminal. So that's why in that way you can turn the motor. If you give high to one and high to other, the motor won't turn because there is no path for the current to flow. The potential difference is zero. When there is potential difference zero, the current won't flow. When you put low and low to both the terminals, even in that case, the motor won't turn. When you put high in one terminal and low in other terminal, only then the motor turns. And when you reverse the polarities, like high to A and B to low, then the motor direction will reverse. That is how. This is the basic logic I am explaining in plain English. I'm not writing any code for you. I'll be sharing you the PPT in which there is the code. If you want me to write the code, I'll write the code here. And also here, without writing any code, even here, I can just use auto generate code. I'll just tell here. I want to build let two-wheel robot car. I'll just do that. Yep. Based upon my connections, it has already initiated the pin modes, and then it has written the logic. See the logic here. High low, it goes clockwise. I mean the motor A, the motor one goes clockwise. Here the motor two goes clockwise. The both goes clockwise. The bot moves forward, and to move backward, the polarities are reversed. See, such a simple logic. And if you want to turn right, you will turn. If you want to turn right, you will turn the left motor clockwise and right motor anti-clockwise. If you want to turn left, reverse. That's a simple logic. I have given the logic in the PPT also. And actually, uh, I don't feel this workshop is satisfactory. Even for me, I don't feel this workshop is satisfactory. So I feel I can conduct an offline workshops where where you guys can come and build your own ESP bots, ESP robots, which you can control with your phones. And also, at the end of the workshop, you will be having a competition. The team which wins the competition will get the ESP bot kit, which costs roughly around 900 rupees, and the workshop price is 250. And if you are interested, I'll do that. I'll redo this. I mean, I won't be redoing any online workshops ever again, because I know even you are not interested in online workshops, and even uh, my content delivery in online is not very much good. So I feel offline is much better, where I can see your faces, help you out, ask your doubts, clarify your doubts. That is much better way what I feel. So I'll give you a link. Please fill it. Please fill this link. I'll send you the certificates. And also, mm, please tell me if you are interested in the offline workshop rather than, I mean, no online ever again, only offline. So if you are interested in offline workshops, we can do that in CBIT. I have talked with the CBIT. You can come there, and I'll be charging only 250. So it's up to you guys. Please fill the form and let me know your interest so that you can go ahead. And if there is anything you want to ask me, please go ahead. I think I don't want to prolong this workshop more. And also, let me show you. Sorry, that. Yep, these are the bots which you will be building in the offline workshops, and you will be going for the competition with those. The team which wins will get the kit of 800. I mean 900 approximately. So I guess that's it, guys. Thank you for joining.